Hi, welcome back to my channel. Today we will discuss on chapter 4.1 Forces. Exercise 1, free body diagram and applications of Newton's law. Okay, so before we apply or we write an equations, the first thing that you need to do is you need to draw free body diagram. So still remember how many forces we have? Okay, so we recall back. Okay, so force, actually we have 5 types of force. The first one is weight, where the direction is always acting downward. The second one is the frictional force, where when there is a rough surface, there is a frictional force and the direction is always opposed to the motion. The third forces is the tension, and tension happens during when there is a string or the wire. Number 4 is the normal force, when there is a contact surface and the directions of the force for the normal force is always perpendicular to the contact surface. And lastly is our external force. Okay, so external force here we also have pushing force or pulling force. Okay, so now let us start with questions number 1. Before you want to write the equation, you must draw a free body diagram first. So always ask 5 questions. Do we have weight? Yes, we have weight, where the weight is always acting downward. Okay, so we have weight. Do we have frictional force? No, because the question didn't mention rough surface. Do we have tension? No, because there is no string. Okay, do we have normal force? Yes, because there is a contact surface, so we have normal force that acting perpendicular to the contact surface. And we don't have external force because there is no pushing or pulling. Okay, so we draw from this origin, we have normal force and also we have weight. Okay, so for these questions, this free body diagram only involve y component. Okay, so our y component is Fy equals to Ma. Okay, so if you look at the questions here says that object is at rest. Okay, so when the object at rest, meaning that our acceleration is equals to 0. Object is at rest, so v equals to 0. When v equals to 0, acceleration also equals to 0. Okay, so this one become 0. So now we write normal force N because it's acting upward, minus weight because weight is acting downward, negative, okay, equals to 0. So therefore normal force is equals to weight. Okay, number 2. Number 2, the question here mentions that the force is acting on object B, okay, and the object B is on the rough surface. Okay, so when rough surface, of course we have the frictional force. So the first one, do we have weight? Yes, weight is acting downward. Okay, do we have tension? No, we don't have tension. Do we have normal force? Yes, normal force because this is a contact surface and your normal force is always perpendicular to the contact surface. Okay, do we have frictional force? Yes, because the external force is pulling upward. Okay, meaning that your frictional force will oppose the direction. Okay, so the frictional force will acting downward. Okay, and this is our external force. So we draw all these forces into the origin here. Okay, so we have mg, the weight, we have normal force, we have frictional force, and we also have external force, the pushing force. So we start from origin, pull it up. So this is our external force. Okay, so meaning that for this questions number 2 here, we have x component and also y component. So we need to resolve it one by one. Fx equals to ma, always start with this equation. And because the question say v is 0, so that's why fx equals to 0. Okay, how many forces involve fx? Okay, so fx here we have the external force where we can resolve it into our external force, we can resolve it into fx to the right and fy upward. Okay, so we write the equation, okay, where fx, we have fx for the external force. So fx we write as f cos theta, okay, and plus negative normal force, because normal force is to the left and is equals to 0. So therefore, our normal force we can write it as f cos theta. Okay, so this is the first equation. Okay, the second equation, of course, is for y component, where fy, the resultant fy equals to ma, and the object is not moving, so therefore it's equals to 0. Okay, so for y component, we have fy and also the weight and also frictional force. So the upper force that acting upward is fy. This fy is different with this. Okay, this fy is our net force. Okay, this fy is our external force for y component. So f external sine theta, okay, plus negative weight plus negative friction because it's opposite direction, because it's acting downward, so it's equals to 0. So therefore, we can write our f external sine theta equals to mg, or the weight plus the frictional force. Okay, so this is our second equation. Okay, later you can do it simultaneously. Okay, next one, question number 3. Question number 3 is, here this is an inclined plane and the question already told you that it is a rough surface. So when there is a rough surface, we have the frictional force. Okay, so first you must ask 5 questions. Always ask, do we have the weight, normal force, friction, tension, and also F external. Okay, so weight, of course, we have acting downward. Normal force, yes, we have, because this is a contact surface. So your normal force will always perpendicular to the contact surface. This is our normal force. We also have friction. Okay, so this object C is not moving. Okay, because of there is a friction that acting upward. Okay, if there's no friction, if this is a smooth surface, this object C will fall down. Okay, so the directions of C suppose is falling downward, so our friction oppose the changes. Okay, oppose the direction, so the frictional force is acting upward. Okay, tension we don't have because there's no string. F external we also don't have. Usually F external they will let you know and they will draw out for you. Okay, either it's pushing or pulling. So for this question, there's no F external, so we transfer it into our free body diagram where we have mg, the weight, we have friction, and we have normal force. Okay, so for inclined plane, we need to assume that this direction is x component and this direction is our y component. Okay, so the equation form here is fx, the resultant of fx equals to ma, and because just now the question say it's not moving, so it's equals to 0. Okay, so x component we have frictional force is acting upward, and we also have weight. Okay, so the angle theta given here is actually similar at the angle theta here. So our weight here, we can resolve it into, okay, we can resolve it into downward and to, negative y and negative x, okay, in this direction. So our weight, we can write it as negative, okay, plus negative because it's weight sine theta because it's opposite and is equals to 0. So frictional force is equals to weight sine theta. First equation. Second equation, of course, is from your Fy, the net force for y component, and is equals to Ma and also equals to 0 because it's static, it's not moving. So for y component, we have normal force acting upward, and we also have W, the weight for y component. So we plus negative weight cos theta and is equals to 0. So our normal force will equals to work done cos theta. Okay, so we have the second equation. Okay, next question. Questions number 4. Okay, questions number 4. Okay, questions number 4. Object B is tied with 2 strings. Okay, and you observe at the questions here, the question say the object is still at rest. Okay, it's not moving. So we draw a free body diagram first. Before you draw, you must also ask 5 questions. So we have weight, tension, friction, normal, and also F external. Okay, so weight, of course, we have. Tension, we also have. If we, let's say we refers to object D, tension is come out from the object. So our tension in this direction. Let's say this is our T1, this is our T2. Okay, frictional force we don't have, okay, because we don't have a rough surface. Normal force we don't have also because there's no contact surface, only string tied on object D. So we don't have normal force. And we also don't have F external because the object, there is no pushing or pulling force acting on object D. Okay, so we transfer it to this free body diagram. We have mg, we have tension T2, and also we have T1 with the angle of theta. Okay, then we write the equation Fx equals to MA, and because it's not moving, so therefore it's equals to 0. Okay, to the right is positive, so T2 positive plus T1. T1 we can resolve it into to the left and upward. So this is T1 x component, this is T1 y component. Okay, so we substitute inside here. Our x component is T1 x, so it's T cos theta equals to 0. So therefore, our T2 is equals to T, or negative, here should be negative, T1 cos theta. Equation number 1. Next, for y component, Fy also equals to MA and equals to 0 because it's not moving. Okay, so y component is upward force T1y. Okay, is equals to plus negative work done equals to 0. So therefore, our T1y will equals to our weight. Okay, next. Questions number 5. So questions number 5, we have object E and also object F. Okay, where we have 2 objects, meaning we have two different, we need to split it into 2 different free body diagram. We need to draw 2 because we have 2 objects. Okay, so look at the first one, F. Similar, always ask 5 questions. Okay, do we have weight, tension, friction, normal, and F external? So for F first, F we have mg. This is F. Okay, we have mg. We have tension. Yes, we have tension. Let's say T1. we don't have friction, we don't have normal because there is no contact surface, and also we don't have external. So this is for F. For E we have weight. Okay, and E, you see there's a string here. Let's say this is tension. So the string, because it's type, if you refer to E, so there is a tension come out from object E. Okay, and also there's another string on the top, so we have another tension. Okay, so this tension acting on F and E actually same tension, so we label it as T1. Okay, and this is T2. Okay, why T1 for F and T1 for E same? Because they are same string. So T1 acting on F, the string acting on F and also E are the same. So we label it as T1. Both are the same. Okay, so this is for object E. Okay, if you observe E only Y component, F also only Y component. Okay, up and down. So we only write Fy. Okay, for E equals to MA and is equals to 0. Okay, so our T2, because it's equals to 0, meaning that it's static, is equal. So we can say T2 actually equals to the upper force equals to T1 plus our weight. Okay, for F, Fy for F equals to MA and is equals to 0. Okay, so we say because it's static, it's balanced, meaning that your T1 will equals to your weight. Okay, so here we have two different weight. This weight we are referring is weight for E. Okay, this weight we refer is weight for E, and this is weight for object F, different weight. Okay, next one we go to questions number 6. Okay, just now this is questions number 5. Okay, questions number 6. Okay, question number 6 is, this one also is an inclined plane. Okay, inclined plane, and the object is pulling upward. There is a force pulling upward. So if you refer to this object, always ask 5 questions. Okay, do we have weight? Do we have tension, friction, normal, or F external? Okay, every time when you want to draw free body diagram, you must ask 5 questions. The first one is, do we have weight? Yes, it's acting downward, straight to vertically downward. Do we have tension? Yes, because there is a string, and if it refers to this object, the tension is out from the object. Frictions we don't have because it is a smooth surface. Okay, the questions didn't mention rough surface, meaning that we assume it's a smooth surface. Normal, yes, because this is a contact surface. So normal force must be perpendicular from the contact surface. And there is no frictional, the external force, because there is no pushing or pulling. So we transfer it into this diagram. We have tension, we have weight, and this is the angle theta, and also we have normal force. Okay, again, because this is an inclined plane, so in this direction, this is x component. In this direction, this one will be our y axis. Okay, so we draw and then we write the equation. The resultant x is equal to ma, and it is moved with constant velocity. So v constant, when v constant, our a is equals to 0. Okay, so again, our f net equals to 0, meaning it is equilibrium, balance. Okay, so our x component, we have t, and also we have w, the weight, where we can resolve down and also to the left. Okay, so this is wx, this is wy. So we can write the equation for x component, where t upward plus negative weight. Weight is weight opposite, so it's sine theta equals to 0. Or we can straight away write t equals to weight sine theta. Okay, because it's static, meaning that force acting upward equals to force acting downward. Okay, it's similar. Next one for y component is Fy equals to ma, and because it's v constant, so it's also equals to 0. So our y component, we have normal force, and here we have Wy, so we can say is actually our normal force is equals to and W weight cos theta. Okay, equation number 2. That's all for this video. We already discussed questions number 1 until questions number 6. Where questions number 1 until questions number 6, all the questions involved is where a equals to 0. Okay, a equals to 0 when v constant, or when v equals to 0, meaning is at rest. So please watch the next video, part 2, where the acceleration is not equals to 0. Thank you.